Hey everybody, thanks for clicking on this video. Today we're going to be looking at modeling sine functions from graphs. This is actually sort of a continuation of the previous video that I'll have linked up at the top, where we were first modeling cosine functions. And I always tell students modeling cosine functions is a little bit easier in some cases, but there actually are a few cases where modeling sine functions are easier. But some teachers, they want you to model all functions with either sine or with either cos or cosine. So I'm showing you both in these different videos. So if you want to follow along, links to the companion worksheet, those are in the description below, so you can click on that. Also, don't forget to hit that subscribe button so you can be up to date on all the videos that we have coming out from this channel. So let's get started. So we have this function graph right here. Now this point is at 9, 4. Now this point down here is at something comma 0. Now what is that? What is that x value? Well, let's work through this. We have these other points right here. And these points are at something 2 because it's at the middle. It's at the halfway point. Now this is at 0 comma 2. Now, from here to here, from here to here, and from here to here, this represents 3/4 of a full cycle. So it's not a full cycle because that would be over here. Now, we know that from this point to this point is 9. So that means from here to here is 3. And then from here to here is 3 more. And then from here to here is 3 more. And then from here to here is 3 more. So this gives us enough information to work with to find our 4 key pieces of information. First, our amplitude. Now we know that our middle is 2. So that means our amplitude is from the middle to the top, which is 2. That's that distance from 2 to 4 or from 2 to 0. Then our period length. We just said that our period length is 12. Now our phase shift. Now for cosine, the phase shift is the x value where it hits its maximum. For sine, it's a little bit different. For sine, it's where it hits the middle going up. So it's not here, it's here. The phase shift is 6. And then the vertical shift is the middle. So that's going to be 2. So now that we've identified the 4 key parts, now we can go ahead and write this equation. So f of x equals 2 sine. Now if you use radians, then it's going to be 2 pi over 12 times x minus 6 plus 2. Or if you use degrees, then it's going to look like this. 2 sine of 360 over 12 times x minus 6 plus 2. Like that. And so whether you're in degrees or radians, the equation will look exactly the same except for having either 2 pi or 360. And of course you can simplify this to pi over 6 and you can simplify that to 30. So let's look at the next one. So here we're given this midline right here, and this point is at 14, 8. And then we have this low point at 4, -2. So from that information, just that alone, we have enough to figure out what our 4 components are. So our amplitude, that's going to be from here to the top or from here to the bottom. And so we look at the y values. And from -2 to 8, that's a distance of 10. The period length. Now we know that from here to here, from 4 to 14 is a distance of 10. Now this is not a full cycle. It's not even a half cycle actually, because from here up to here, that's a half cycle. So from here to here is 10, and from here to here is 10. So it's 20 for a half of a cycle. So for a full cycle, our period length, that's going to be 40. Now our phase shift, again, with cosine, it's at the top, at this x value. But for sine, we want it here, at the middle when it's going up. So that is a value of 14. And then the vertical shift, that is the midline. That is right here. That is a value of 8. So that means f of x, we can write our formula since we have our 4 components. 10 sine of 2 pi over 10 times x minus 14 plus 8. Or, if we are in degrees, f of x equals 10 sine of 360 over 10 times x minus 14 plus 8. Again, this will simplify to pi over 5, and this will simplify to 36. So on the second page, here we have this function. Now what's nice is that the middle is right on the x-axis, which makes the amplitude and the vertical shift very easy. So the amplitude is 20, because it goes from 0 up to 20 and from 0 down to negative 20. Now the period length. Now this one's a little tricky because from here to here is a length of 1, but we have 1, 2, 3, 4 cycles. And so we want to know, all right, if 4 cycles takes up a length of 1, then 1 cycle should take the length of 1/4. So that's our period length. Now our phase shift. I'm going to leave this blank for the moment and just write down our vertical shift. And that is 0. It's right along the x-axis. Now, this problem is much easier for cosine. Why? Because it starts right at the top. That's what cosine likes to do. But since we're doing this for sine, it's a little bit trickier, but it can be done. The question is, where is this spot? Right here. And so we're going from the top back down to the middle. And so this represents 1/4 of a period length, or 1/4 of the cycle. Now, since this is 1/4 of the cycle, and we already know that it's 1/4 already, then that means this value should be 1/4 times 1/4, 1/16. So that point should be at negative 1/16, comma, 0. It's negative because it's off to the left of the origin. So we have negative 1/16. And that's the thing to remember, is that if you can break it up into half cycles and quarter cycles, then if you know the period length, then you just multiply by either 1/2 if you're dealing with a half cycle, or 1/4 in this case because we dealt with a quarter cycle. But now we have enough information to write our formula. So 20 sine of 2 pi over 1/4 times x minus negative 1/16. And we'll simplify this because 2 pi over 1/4, we don't divide fractions. Instead, we multiply by reciprocals. So that's going to be 8 pi, and that's x plus 1/16. And then in degrees, we have 20 sine of, well, let's see, instead of 2 pi, it's going to be 360. And instead of dividing by 1/4, let's multiply by 4. So that's multiplying by 2 twice. So 360 times 2 once is 720. Twice is going to be 1440. And then it's going to be x plus 1/16. All right. Now for our last one, here we have these 2 points. And so if I draw in the midline right here, this is going to be halfway between negative 8 and positive 2. Well, to find the middle of that, we take negative 8 plus positive 2, which is negative 6, and divide by 2, so that's a negative 3. And so from negative 3 up to 2, or negative 3 down to negative 8, is a distance of 5. So the amplitude, that is 5. Now for our period length. Now here, from this spot to this spot, this is a half cycle. So from 70 to 130 is a length of 40. So we want from here to here. That gives us a full cycle. And so that is a length of 80. Now our phase shift. Now again, since we're dealing with sine, we want to know where does it hit the middle going up. So we want this point right here. Well, it has to be halfway between these 2 points. So the halfway point between 70 and 130 is 90. The halfway point between -8 and 2, well, we already found that. That's -3. So our phase shift for sine is 90. And then finally our vertical shift, which we just found, that is the midline. That is -3. So now we've got our 4 components, so we can write our equation. So f of x equals 5 sine of 2 pi over 80 times x minus 90 minus 3. And in degrees, that would be 5 sine of 360 over 80 times x minus 90 minus 3. And this can simplify because you can simplify that to pi over 40. Here you can drop the zeros and say 36 over 8. So you can divide by 2 once and get 18, divide it a second time and get 9. So you could simplify that and be left with 9 halves. Thanks for watching, everyone. If you liked the video, please give it a thumbs up. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the best way to understand something is to do it.